Hello friends, welcome back to Cloud Pedagogy. In the last session, we have discussed about elastic load balancing and its basic concepts like features of elastic load balancing and components of load balancing. In today's session, we will extend our discussion with the types of elastic load balancers. Now, there are several types of load balancers that you can choose from. In AWS, here is the application load balancer that load balances HTTP and HTTPS traffic. There is the network load balancer that load balances TCP, UDP and TLS traffic. And there is the gateway load balancer which is mostly for routing traffic to third-party applications. Let's first understand what is application load balancer. ALB routes traffic based on request data. It makes routing decisions based on the HTTP protocol like the URL path and host, as well as HTTP headers and methods, and also the source IP address of the client. This enables granular routing to the target groups. Next, send responses directly to the client. ALB has the ability to reply directly to the client with a fixed responses like a custom HTML page. It also has the ability to send a redirect to the client, which is useful when you need to redirect to a specific website or to redirect the request from HTTP to HTTPS, removing that work from your backend servers. Next, ALB supports TLS offloading. Speaking of HTTPS and saving work from backend servers, ALB understands HTTPS traffic. To be able to pass HTTPS traffic through ALB, an SSL certificate is provided by either importing a certificate via IAM or AWS Certificate Manager services or by creating one for free using ACM. This ensures the traffic between the client and ALB is encrypted. Next, authenticate users. On the topic of security, ALB has the ability to authenticate the users before they are allowed to pass through the load balancer. ALB uses the OpenID Connect protocol and integrates with other AWS services to support more protocols like SAML, LDAP, Microsoft AD and more. Next, secure traffic. To prevent traffic from reaching the load balancer, you configure a security group to specify the supported IP address ranges. ALB uses the round-robin routing algorithm and also it ensures each server receives the same number of requests in general. This type of routing works for most of the applications. ALB uses the least outstanding request routing algorithm too. If the requests to the backend vary in complexity, where one request may need a lot more CPU time than another, then the least outstanding request algorithm is more appropriate. It's also the right routing algorithm to use if the targets vary in processing capabilities. An outstanding request is a request when a request is sent to the backend servers and a response has not been received yet. For example, if the EC2 instances in a target group are not the same size, one server's CPU utilization will be higher than the other if the same number of requests are sent to each server using the round-robin routing algorithm. The same server will have more outstanding requests as well. Using the least outstanding request routing algorithm would ensure an equal usage across targets. ALB has sticky sessions. In the case where requests need to be sent to the same backend server because the application is stateful, then use the sticky session feature. This feature uses an HTTP cookie to remember across connections which server to send the traffic to. Finally, ALB is specifically for HTTP and HTTPS traffic. For example, in our student directory application, we will be load balancing only the web traffic. So, we will be using application load balancer or the ALB. When you create ALB, you will need to configure three main components that we have already discussed in the last session. So if your application uses a different protocol, then consider the network load balancer. Here are some primary features of the network load balancer that we are going to discuss. Network load balancer supports TCP, UDP and TLS protocols. HTTPS uses TCP and TLS as protocol. However, NLB operates at the connection layer, so it doesn't understand what a HTTPS request is. That means all features discussed above that are required to understand the HTTP and HTTPS protocol, like routing rules based on that protocol, authentication, and at least outstanding request routing algorithm are not available with NLB. But NLB uses a flow hash routing algorithm. The algorithm is based on the protocol, the source IP address and source port, the destination IP address and destination port, and the TCP sequence number. If all of these parameters are the same, then the packets are sent to the exact same target. If any of them are different in the next packets, then the request may be sent to a different target. NLB also has a sticky sessions. Different from ALB, the sessions are based on the IP addresses of the client instead of a cookie. NLB supports TLS offloading. NLB understands the TLS protocol. It can also offload TLS from the backend servers, similar to how ALB works. Next, ALB handles millions of requests per second. While ALB can also support this number of requests, it needs to scale to reach that number. This takes time. NLB can instantly handle this amount of requests. NLB supports static and elastic IP addresses. These are some situations where the application client needs to send requests directly to the load balancer IP address instead of using DNS. For example, this is useful if your application can't use DNS or if the connecting clients require firewall rules based on IP addresses. In this case, NLB is the right type of the load balancer to use. NLB preserves source IP address. It preserves the source IP address of the client when sending the traffic to the backend. With ALB, if you look at the source IP address of the request, you will find the IP address of the load balancer. While with NLB, you would see the real IP address of the client, which is required by the backend application in some cases. The next load balancer is Gateway Load Balancer. Gateway Load Balancer helps you easily deploy, scale, and manage your third-party virtual appliances. It gives you one gateway for distributing traffic across multiple virtual appliances while scaling them up or down, that too based on your demand. This decreases potential points of failure in your network and increases the availability. Let's see some of the primary features of the Gateway Load Balancer. Deploy third-party virtual machines very faster. Gateway Load Balancer takes care of scaling, availability and service delivery so that the AWS partner network and AWS marketplace can deliver virtual appliances more quickly. With Gateway Load Balancer, you can also work with select partners that offer fully managed secure solutions, such as making it easier to set up infrastructure security services within minutes. Next, scale virtual appliances while managing costs. Hitting the limit of what your virtual appliances can handle can bottleneck your entire network. To prevent this, Gateway Load Balancer automatically scales your virtual appliances up or down, again based on your demand. Next, improves your virtual appliance availability. To ensure your virtual appliances are available and healthy, Gateway Load Balancer runs health checks on a configurable sequence way. So that's all about the different types of ELBs. But how do you select between the ELB types? Selecting between the ELB service types is done by determining which feature is required for your application. As you can find a list of the major features that you learned in this unit and previous units. So that's all for today's session. We will meet again in my next video with the implementation of these concepts in practical with our student directory application. Thanks for watching and see you again in my next lecture. Until then, take care.